Once a line has been measured, it is necessary to convert the measured length into a horizontal length. The most convenient way of doing this is to apply a series of corrections to the measured length, and in direct distance measurement, there are 5 possible corrections which have to be considered. These are standardization, slope, tension, temperature, and sag. When using synthetic tapes and metal chains, only the standardization and slope corrections apply, and the best possible accuracy that can be achieved is in the order of 1 in 1,000. When using steel tapes, if only the standardization and slope corrections are considered, the best possible accuracy that can be obtained is in the region of 1 in 5,000. If the tension and temperature corrections are taken into consideration, the accuracy can be increased to better than 1 in 10,000, and 1 in 20,000 is possible on smooth surfaces. The sag correction only applies if the tape is suspended in catenary, and this is rarely done nowadays. These 5 corrections are now considered in turn. When using tapes and chains, you must not assume that they are as long as they appear to be. Synthetic tapes and metal chains can become stretched with continual use, or repairs may alter their length. So, the actual length of a tape must be found by measuring it against a reference steel tape, which should only be used for checking and never for fieldwork. Measurement takes place on a flat, smooth surface both before and after survey work. The mean of the 2 measurements gives the standardized length of the tape or chain. This is used to calculate a standardization correction to be applied to the measured length of the line. For example, a line AB is measured using a tape laid along the ground surface and found to be L meters. If the tape has a nominal length of L and a standardized length of L dashed, then the standardization correction is given by this formula. It can be positive or negative depending on the values of L and L dashed. When measuring along the ground surface, the ground will almost always be sloping, so the distance obtained will be the slope distance. If a horizontal distance is required, it is necessary to change the slope length L into the horizontal distance D. This can be done in a number of ways. If the angle of slope, theta, has been measured using a theodolite, for example, then D equals L cos theta. If the difference in height between A and B has been measured by leveling, for example, then by Pythagoras' theorem, D equals the square root of L squared minus delta H squared. Although both of these formulae give horizontal distance, it is preferable to turn them into corrections to be applied to the original measured length L. The slope correction equals L multiplied by 1 minus cos theta, if the slope angle is known, and delta H squared divided by 2L, if the height difference is known. These are always subtracted when converting slope lengths into horizontal lengths. The tension correction need only be considered when using steel tapes where high accuracy is required. The steel used to make steel tapes is elastic in nature, and if the tape is pulled, its length will change slightly depending on the amount of pull or tension applied to it. To allow for this, all steel tapes are manufactured and calibrated with a standard tension applied. For example, 5 kilograms force, which is about 50 newtons. The value used for any particular tape is written near its zero end. When using a tape, if it is pulled at its standard tension, there will be no change in its length due to tension, and so no correction is necessary. Tension can be applied to a steel tape using a spring balance hooked into a roller grip which clamps onto one end of the tape while the other end of the tape is held firmly. The spring balance is pulled until the required tension is registered on its sliding index. If the tape is pulled at any other value than its standard tension, then its length will be different and a correction will be necessary. For a line measured as L, this is given by L multiplied by TF minus TS divided by AE, where TF is the actual tension applied to the tape, TS is the tension at which the tape was calibrated, A is the cross-sectional area of the tape, and E is the modulus of elasticity of the tape material, a typical value for steel being 200,000 newtons per square millimeter. The tension correction can be positive or negative depending on the values of TF and TS. The temperature correction is also only applicable to steel taping, and then only if high accuracy is required. Not only will the length of a steel tape change if it is pulled, it will also change if its temperature changes. To allow for this, when they are manufactured, they are calibrated at a standard temperature, usually 20 degrees C, and the value used is also written near the zero end of the tape. Special surveying thermometers are used to take the temperature of the tape. These are laid beside the tape on the ground and left in position until steady readings are obtained. Strictly, the temperature at each end of the tape should be taken and a mean value used. If its temperature is different to the standard value, then its length will change and a temperature correction will be necessary. For a line measured as L, this is given by alpha L multiplied by TF minus TS, where alpha is the coefficient of expansion of the tape material, typically 0.00000112 per degree C for steel. TF is the actual temperature of the tape, and TS is the temperature at which the tape was calibrated. The temperature correction can be positive or negative depending on the values of TF and TS. The sag correction is also only applicable to steel taping and is only used on rare occasions when the tape sags under its own weight, forming the shape of a catenary curve. So it is also known as the catenary correction. It is usually necessary to apply a tension to the tape to keep it suspended. The measured length is L, and the sag correction is applied to this to give the straight line distance LS. The correction is omega squared multiplied by L cubed multiplied by cos squared theta divided by 24 TF squared, where theta is the angle of slope between the tape supports, omega is the weight of the tape per meter length, and TF is the tension applied to the tape. This correction must always be subtracted if horizontal lengths are required.